In this lesson, we'll be going over particle motion. This is often represented as position, velocity, and acceleration functions of any particle or object moving through a medium. Keep in mind that throughout this presentation, the leftmost graph represents position, the middle velocity, and the rightmost acceleration. Here, a person is constantly accelerating or going faster. In the leftmost graph, we see that Abhishek's position relative to time is increasing as time continues. The longer Abhishek is moving, the faster he is getting. In the middle graph, we see that Abhishek's velocity is constantly increasing. This graph is a straight line because it is the derivative or the slope of the graph of the position versus time graph. In the rightmost graph, the person's acceleration is constant because it is, like velocity is position, the derivative of the velocity graph. Essentially, velocity is the rate at which position changes, and the acceleration is the rate at which velocity changes. In this segment, we see Connor walking at a constant speed. His position is increasing at a constant rate, making the graph a straight line, which is what you see on the left side of your screen. Since his position is constantly increasing, that must mean his velocity is a constant number shown in the middle graph. It is a constant positive number because he is going at a positive speed at a constant rate. In this case, there is no acceleration, making it zero on the graph. This is because Connor's velocity is neither increasing nor decreasing as time goes on. He is moving at a constant speed, and the derivative of any constant is zero. Now this motion is slightly more complex. We see that Will's position increases at a rate which is constantly slowing down, and he eventually returns to his original position, which makes an upside down parabola. Since his velocity is decreasing, we see that the velocity graph has a negative slope. It is worth noting that when x is about 2, the position graph reaches an apex, and this is when the velocity graph is 0 on the y-axis. This is because at this point, the position function has a slope of 0 since Will is not moving for a split second, and the velocity begins to become negative. The acceleration of this motion is a constant negative number because although Will starts moving in a positive direction, he's slowing down in the opposite direction, and then eventually goes that way, showing that the acceleration is acting against the initial direction of motion. Here, Justin is showing particle motion with a constant position. The position graph is a constant number because we chose to set our frame of reference at 0 at the furthest left side of the screen. Since Justin is not moving, the velocity graph shows a constant value of 0. Mathematically, this can be proven by showing that the derivative of a constant is 0. In addition, the acceleration graph is 0 because Justin is neither speeding up nor slowing down in any direction. He is just standing still. This is easily the most complex particle motion in our presentation. In this case, the particle of interest is the baseball being thrown between Will and Justin, and its position is at 0 when Will has the ball. Disregarding the time that it takes to throw the ball, the particle is moving jaggedly between the two students. It first moves to Justin and then to Will in a repeating motion, which shows that the position of the particle creates what looks like sharp teeth. The velocity graph in this situation is the most difficult to understand. When the ball is thrown, it is moving at a constant speed. From Will to Justin, it has a positive velocity, and from Justin to Will, it has a negative velocity. Since Justin's position is positive relative to Will's, the lines at each side of all changes in velocity are present because any point on a graph is indifferentiable and goes to either positive or negative infinity, but that will be explained later. Since each instance at which the ball is thrown has the same velocity, the acceleration graph shows a constant 0.